In today's digital world, having a website or web application is essential for any business. But have you ever wondered how the internet knows where to send you when you enter a website's domain name? It's not magic, it's a system that's been in place for decades. The system is called DNS, or Domain Name System, and it's responsible for translating human-readable domain names into IP addresses that computers can understand. But managing DNS can be a complex and daunting task, especially for businesses that want to ensure their website is always available to their customers. That's where a powerful and reliable service like Amazon Route 53 comes in. Amazon Route 53 is a highly scalable and reliable DNS web service provided by Amazon Web Services. So, are you ready to learn more about Route 53? Let's dive in.
Hello everyone and welcome to the most awaiting video on this channel. Yes, let's talk about Route 53. And before this, let me start by saying that Route 53 is an impressive and reliable domain name system web service offered by Amazon. It's highly scalable and available, which makes it a top choice for businesses of all sizes. By the end of this video, I guarantee that even if you are a beginner, you will have a clear and confident understanding of how Route 53 works. So let's dive right into it. Fascinatingly, Route 53 is named after the port number 53, which is used for DNS traffic. Now, you might be wondering what DNS is and why a service like Route 53 is necessary. So let's start with what is Domain Name System or DNS. A general user of the internet might not realize that when they enter a web URL in the browser, there's a lot happening behind the scenes. But in simpler terms, what's happening is that the domain name is getting mapped to a combination of numbers, also known as IP addresses. This process is necessary for computers to communicate with each other over the internet, and DNS plays a critical role in making it happen seamlessly. And when a user types in a website like google.com, they are essentially making a request to see what's hosted on that particular website or URL. This request is served by a web server, which then checks with the DNS server and asks, where can I find the website for google.com? The DNS server then responds with the IP address where the website is hosted. In simpler terms, this is what happens when you enter a web URL in your browser. However, there's a lot more to this than just this basic process. In a client-server architecture, the client, which is typically us, makes requests to a server to get the details we want. Similarly, when visiting a website like bestbuy.com, we are essentially making a request to access that website. When we make a request to access a website, the DNS server responds to us with the resolved IP address, which allows us to connect to the actual server hosting the website. For example, the resolved IP address for a website could be 192.168.122.22. Note that this is just an example, but I hope you're understanding the point here. And when we say that Route 53 is a domain name system web service, we mean that it provides a highly available and scalable DNS infrastructure that enables developers to manage DNS traffic for their domain names. In other words, Route 53 allows developers to route end users to internet applications by translating domain names like bestbuy.com into IP addresses that computers use to connect to each other. Route 53 is a powerful and scalable DNS service offered by Amazon Web Services, and the DNS that we have here maps domain names like example.com, flipkart.com, pythoholic.com, or bestbuy.com to IP addresses like 192.0.21 or 192.168.64.25. And with Route 53, you can manage and route traffic to resources such as web servers, email servers, and much more. But you need to remember the three things that Route 53 is going to help you with. First is domain registration. Second is DNS routing. Third is health check. Let's move forward with discussing Route 53 and its capabilities in managing DNS infrastructure for domain names on AWS. Websites like Google, Flipkart, Amazon need to be hosted somewhere for users to access them. We know that. And with AWS, we can host a website and provide users with the URL to connect to. This is where Route 53 comes in. It helps manage internet traffic to our domain names, ensuring users are directed to the appropriate resources and that's how it makes life easier. This is the end user which is connecting to the website, and here we have the DNS Resolver. For now, just think of it as a directory where we resolve the queries on behalf of the end user. And with AWS Route 53, we return the IP address of the DNS records that are queried by the DNS resolvers. Resolving DNS queries means converting a user-friendly domain name into a computer-friendly IP address. When a user enters a website domain name in their browser, their device's DNS resolver sends a query to the DNS server to find the IP address associated with that domain name. It also helps check the health of the endpoint for high availability so that we know everything works fine. And Route 53 also provides a user-friendly interface for creating hosted zones, managing traffic policies, and propagating DNS records to its global network of authoritative DNS servers. Don't worry if these terms sound unfamiliar, we'll explore them one by one. And it also helps connect the endpoints or the endpoint instances where the website is actually hosted. And for monitoring and logging and analysis, we make use of CloudWatch by setting alarms and notification mechanisms. And all of this is provided to you by AWS with Route 53. Let's get to the root of it. A DNS resolver is a crucial component in the domain name system. When a user enters a website's domain name in the web browser, the DNS resolver on the device sends a query to a DNS server to look up the IP addresses associated with that domain, or the IP address associated with that domain. This process allows us to connect easily to websites without the need to remember their IP addresses. And DNS resolvers makes the internet more user-friendly, and their importance cannot be overstated, isn't it? Let's suppose we want to make a call. Let's call Susan, our friend. Now we make a request to our voice assistant and ask her to call Susan. What she does is she checks your phone contact database and finds the number and then makes the call. And the voice assistant, I'm sure she doesn't know who Susan is, but it confidently resolves the phone number from the name query and makes the call. This example might seem a little bit of more of a oversimplified version of how DNS works, but it was actually designed based on this concept. Let's suppose you want to tweet. For that, you would want to go to Twitter. So when you type the URL for Twitter, that is www.twitter.com on your browser, the first thing we need to check is where is www.twitter.com. So this is done through a process called DNS, a domain name system lookup. Your browser sends a request to the DNS server to look up the IP address associated with the domain name you entered. In this case, it's twitter.com and the IP address is 157.233.2.0. Once the browser knows the IP address of the website, it establishes TCP connection with the server that hosts the website, and then the server receives the request and processes it. It receives the requested content and sends it back to the browser as an HTTP response. And this is what happens when you try to visit a website. And now let's talk about domain registration. So domain registration is a process of acquiring a unique name that identifies a website on the internet. And here we have the website URL. Let's take this as an example. So we have https://www.google.com/search a query which is equal to example. So this is a basic URL, the example URL, and we'll understand what these different sections actually mean. So the first one is protocol. So a protocol is a set of instructions for two computers to talk to each other, and it provides a set of rules for how data should be formatted, the order in which the message should be sent, and how to handle errors or problems. One commonly used protocol is HTTPS, which stands for Hypertext Transfer Protocol Secure. You already know HTTP, I guess. So this is a secure version of HTTP, that is HTTPS. Second one is domain itself, which is our www.google.com. And if you want yours, you can get it on Route 53, or you can visit Hostinger or GoDaddy.com. Here www is called the subdomain. A subdomain is like a subcategory or subsection of a larger domain, which is google.com. And as you can see, we have a /search here, which is also called as page path. A page path is like an address or location that helps identify a specific page on a website. Think of it like a book in a library, where the main domain name is equivalent to the library, and the page path is like the specific shelf or location within the library where a particular book can be found. This analogy can help you understand how a URL actually works. Next one is the query string. A query string is a way to add extra information to the end of the URL to help the website process request and provide specific information. So let's suppose we are searching for a query, and that query is basically your example. So it will help the website to get that data for you. For example, in this URL, the query string is q equals to example, and it tells the website to perform a search for the term example. I hope you got the point. Now, when it comes to registering a domain name for your own website, there are many domain registrars out there that can help you with the process. Some popular domain registrars are GoDaddy.com, Namecheap, and Bluehost. The process actually typically involves searching for an available domain name, selecting a registration length, and paying a fee to secure the domain name. Once the registration is complete, the domain is yours to use for your website. Keep in mind that domain registration fees are typically recurring, so you will need to renew your registration periodically to keep your domain active. It's not for lifetime. So when you want to register a domain name for your website, you need to go through a domain registrar. So this is the company that manages the registration of domain names and helps you find an available domain name that suits your needs. When searching for an available domain name, you can use a domain registrar's website like Hostinger or GoDaddy. These websites provide a search bar where you can enter the domain name you want and check if it's available or not. Once you find an available domain name that you like, you can actually proceed with the domain registration process. So if the domain name that you want is available, then you can register it by following the instruction on the registrar's website. The registrar has a registry that keeps all the records so that it can inform the registrar that if the domain is available or not. And there is one more important factor here, which is called ICANN. So ICANN is basically your Internet Corporation for Assigned Names and Numbers. It is a non-profit organization that plays a crucial role in managing the Internet's domain name system. And ICANN actually manages the root zones of the DNS, which includes the list of all top-level domains or TLDs, such as .com, .org, and .net. So when I talk about top-level domains, I might say TLDs. So don't get confused. TLD is basically your top-level domain, or imagine .com, .org, .net. So once everything is done, you will need to provide some personal information and payment details and pay for the domain, and then you can make use of the domain that you purchased. Great, isn't it? Now let's talk about DNS routing and what exactly happens when you type in the website name that you wish to browse. Here I'm trying to connect to twitter.com. So a DNS or domain name server is like internet's phone book, which helps you convert the domain name into IP addresses. But you might ask me why it is needed. So when you type a URL into your browser, it goes through a DNS resolver, which acts as a middleman between your computer and the other 3 DNS servers. The first touch point of the resolver is the root name server, which helps find out what top level domain or TLD the domain uses, like .com, .org, .net. Now here you can see TLD for twitter.com is .com. So once we get that, it passes it on to the .com TLD server. So after that, the .com TLD name server contacts the Twitter authoritative server, which in turn converts the domain name into an IP address. And that's what is sent back to our computer. And we get content to our browser because the browser now understands that twitter.com is 157.233.2.0. And all this happens so fast that you won't notice it until and unless you're using a dial-up modem with a connection of 64 kbps. And that too would be highly impossible. I'm just joking. Now let's talk about domain levels. So everything that we work on starts at the root, that is the dot. The root level domain chain refers to the hierarchy of domain names in the domain name system. So that is basically your dot. Below the root level domain are the top level domains or TLDs. I hope you remember this, such as .com, .org, .net, .edu, .gov, and so on. Below the TLDs are the second level domains, or also called as SLDs, such as google.com or netflix.com, rootserver.net, netnode.se. And finally, there may be third level domains such as www.google.com, or it could be blog.wordpress.com, which are subdomains of the second level domains SLD and represent a specific service or resource on that domain. So now you know that there are levels of domains as well, and they have their own specific use cases. And now let's recap this once again. So root server, when a DNS resolver receives a request for a domain name that it does not have cached locally, it requires a root server to find out which authoritative name server it should contact next to get the information. So as I already told you that it has a .com. So the top level TLD server actually contacts the .com for Twitter, and that is where we go to the TLD. So TLDs are responsible for managing the resolution of domain names for a specific top level domain. So here we have .com. So based on that, it actually sends the request to the authoritative server of Twitter, and then the DNS server actually then resolves the authoritative name server to obtain the IP address for the domain name. And that's how we connect to twitter.com. Let's simplify things even further. Now you want to visit a website that is twitter.com. You hit the URL and your browser talks to the DNS to find out the IP address associated with that. If it has the IP in its cache, translates it and sends it back to you. If not, the name server makes use of something called the NS record or name server record, which is a type of DNS resource that specifies the authoritative name servers for a particular domain. Now you see, we went one step further on reaching to the auth name server or authoritative name server. Here this record contains information about the name servers responsible for answering DNS queries for the domain, including their domain names and IP addresses. So once you get back the information, you send it to the browser again, and that's how it works. So when you want to visit a website, you hit the URL and your browser talks to the DNS to find out the IP address associated with it. If the name server has its IP address in its cache, then fine. Then if the name server, if it has the IP address in its cache, then it translates it and sends it back to you. If not, the name server makes use of something called the DNS or the NS record or name server record, which is a type of DNS resource record that actually specifies the name servers for the particular domain. Here, this information contains information about the name servers responsible for answering DNS queries for the domain that you want, that is twitter.com, including that domain names and IP addresses. And once you get the information back, you send it back to the browser. And that's how you visit the website. And without DNS records and rules, the internet as we know, it would be impossible. They allow our devices to communicate with servers and websites using human readable domain names instead of complex IP addresses, making it easier for us to access the wealth of information and services available online. So let's start off with DNS records. DNS records are like the playbook or the phone book of the internet. They help computers find websites and other useful online stuff by translating the name into the secret code that computers use to talk to each other. Every DNS record holds specific data about or specific details about a website, like it's a secret code where it sends emails and what other names it goes by. And the secret codes that you know are the IP addresses. And there are many different types of DNS records, each with a specific purpose. Some common type of DNS records include A record, associates a domain name with IP address, IPv4 address. AAA records that we have here associates a domain name with IPv6 address. MX record specifies the mail server responsible for accepting email messages on behalf of a domain name. CNAME records maps one domain name to another domain name, and these four are really important. Very, very important. A records, quadruple A records, CNAME records, NS records, and MX records. Let's go back and let me actually explain you with another example so that you can understand why DNS records are so important. So let's suppose you want to visit a website like flipkart.com. You type the URL into your web browser and hit enter. your computer sends a request to the DNS server to resolve the domain name www.flipkart.com into a IP address. That's what we understood right now till now. So here what happens is the DNS server actually looks for the relevant DNS records for www.flipkart.com. If it finds an A record for flipkart.com that maps to the IP address 192.168.22.3, let's suppose, it actually returns this IP address to your computer. Your computer then uses this IP address to connect to the web server hosting flipkart.com, and the website is loaded into your browser. In this scenario, the DNS record or the A record that I said, which maps a domain name to a IPv4 address, that is 192.168.22.0, played a critical role in translating the human readable domain name, that is flipkart.com, into the machine readable IP address. Without the DNS record, your computer would not be able to locate the website you wanted to visit because there is no entry. As I already told you, it's like a phone book. It needs records. So that is why it is mentioned here that DNS record is a database record used to map a URL to an IP address. So DNS records are stored in DNS servers and work to help users connect their websites to the outside world. So there can be records which map IPv4 addresses, like domain to IPv4 addresses, and quadruple A that maps IPv6 addresses from domain names. And another example of the importance of DNS records is with the email delivery. So when you send an email to someone at the domain name flipkart.com, your email server needs to know which mail server to use to deliver the message. And this information is provided by the MX record. That is what I told you. And that MX record is for the flipkart.com. It could be smtp.flipkart.com, which specifies a mail server responsible for handling email for that domain. That is why records or DNS records are really important. Because let's suppose you have a phone book and you don't have any numbers or names representing those numbers, then what's the use? So let's suppose you want to create a record. So a record actually points to an IP address for a website or a domain name. So you want to map the domain name example.com or flipkart.com or pythoholic.com to the IP address, some IP address, for example 192.0.2.1. So you would create an A record in the DNS for example.com with the following information. So the information will be, you will provide name, which will be flipkart.com or twitter.com. The type will be A because that's the A record, and the value of the IP address associated with that. And similarly, if you want to see what's the A record, just you can type NSLookUp -type equal to A space the website's name in the command line. Let's see the next one. There's the quadruple A record. So a quadruple A record in DNS is used to map a domain name to an IPv6 address. So you would create a quadruple A record in the DNS for example.com or flipkart.com with the following information. So the name will be example.com, type will be quadruple A, value will be the IPv6 address. And we have the next one, that is the CNAME record. That is very important as well. That is a canonical name record that is used to alias one domain name to another. Suppose you have a website with domain name www.wordpress.com and you want to create an alias for it like blog.wordpress.com. So you would create a CNAME record in the DNS for blog.wordpress.com, and the information that you will provide is the name, that is blog.wordpress.com or example.com. The type will obviously be CNAME and the value will be www.wordpress.com or example.com or the one that you want. And another one is basically your NS record. So this is basically to delegate a domain name to a set of authoritative name servers. So ns1.example.com is basically your authoritative name server. So let's suppose you have a domain name example.com and you want to delegate the responsibility of managing the DNS to a set of authoritative name servers. So you create a DNS for that, like name is equal to example.com, type will be NS, and the value will be ns.example.com. And the last one that we have here is MX. So MX is basically a mail exchange record. It is used to specify the mail servers that are responsible for accepting email addresses or email messages on behalf of the domain. So what you do is you create a example.com, or let's suppose in our thing like gmail.com. So if the type is MX, and priority is a parameter used in MX records to specify the order in which mail server should be used to handle emails for a domain. Now that we have discussed at length about DNS records, there is something really important to discuss next, that is, yes, DNS rules. So DNS rules are like the laws that govern how the internet domain name system actually works. They tell us how domain names are organized, how different servers communicate with each other, and more. So let's talk about DNS rules. So as we already know that DNS rule is the set of configuration settings that determine how DNS queries are resolved for a particular domain or a set of domains. So let's suppose you own a domain called Pythoholic.com and you want to create a routing rule that points the subdomain blog.pytholic.com to a specific IP address. So the rule that you see here is basically name is blog.pytholic.com, type is A, routing policy is simple, value is 192.0.2.1. So the name, this is the domain name that you want to map to an IP address. In this case, it is pytholic.com. Type is basically this specifies the type of DNS record that you're creating. In this case, it is a record, which is used to map a domain name to an IPv4 address. The routing policy, this specifies how Route 53 should route traffic to the specified resource. In this case, it is using a simple routing policy, which simply returns the IP address specified in the value field. And the value, the most important thing, this is the IP address that you want to map to the domain name. And in this case, it is 192.0.2.1. These are examples. Don't take this in a literal sense. This IP address could be anything. And on the other hand, DNS record is a specific piece of configuration data that provides information about a particular domain or host. So this contains the record information. So a record will be blog.pytholic.com. And the next one we have is MX record, CNAME record, and TXT records. These are multiple ways of defining a record. And DNS records actually provide specific information about a domain or host, while as DNS rules define how that rule or how that information is managed and resolved. So if I say create a record for pytholic.com, but how that should be resolved is given by the DNS rules. So let's suppose you create a blog.pytholic.com here, and how it should be routed is basically having the name pytholic.com, type is equal to A, routing is simple, and value equal to this. But you would be interested in knowing that DNS rules is not a commonly used term at all. However, there is a similar term DNS zone file, which is a collection of DNS records for a particular domain or subdomain. And a DNS zone file contains information about the domain name and its associated IP addresses, mail servers, and other DNS records. And DNS rule is not a standard term in Amazon Route 53, but routing rules can be created to control the routing of traffic to different resources based on specific criteria. So I hope you got the point here. Don't get confused. A rule is nothing but a set of configuration settings that determine how DNS queries are resolved for a particular domain. So let's suppose I want to resolve it by having a simple routing policy. So I'll add the simple routing policy as my routing policy rule, and the value will be the IP address that I want to point it to. And the DNS record will be the important factor here, because that will provide the specific information or the configuration about a particular domain or host. Now that we have discussed about the users and the DNS resolvers at length, now let's move on to the service itself, that is Route 53. And let's talk about the resolver and the health check. Do you want to ensure the high availability and low latency for your applications and services? Look no further than Amazon Route 53 hosted zones. So here it is. Let's talk about AWS Route 53 hosted zones. A hosted zone is like a container that holds information about a specific domain name, such as www.amazon.com. So think of it like a phone book for the internet. When you type in a website address in your browser, your computer needs to look up the corresponding IP address to find the right website that we have already discussed. So a hosted zone holds the information that tells your computer which IP address to go to for a particular website address. So this is the main thing. And by managing your hosted zones, you can easily change the information that your computer uses to find the right websites. It is an essential part of how the internet works, and understanding this is the key to managing your website domain name and routing your website traffic to the right place. And that's why it is written here. It's a place where you can store the DNS records that tell the internet where to find your website, where to send email, and how to access other resources associated with your domain name. So you might be getting confused that what is a hosted zone and why it looks similar, or why it sounds similar to the DNS zone. So I'll tell you one thing. It is basically like DNS zone is the standard DNS equivalent of a Amazon Route 53 hosted zone. So it is a portion of the DNS namespace that is managed by a specific authoritative DNS server and contains the DNS resource records that define how a domain should be resolved. And that's what hosted zone also does. So that is the equivalence that you can draw from. And there are two types of hosted zones. So one is basically your public hosted zone. So a public hosted zone is a type of hosted zone in Route 53 that is publicly accessible on the internet. It contains DNS records that map domain names to corresponding IP addresses or other resources that are publicly accessible on the internet, such as web servers, email servers, or load balancers. And when you create a public hosted zone, you can specify the DNS records for your domain name and make it accessible to the internet. Remember, public hosted zone is a type that is publicly accessible on the internet. Remember that. And we have another one that is called private hosted zone. A private hosted zone, I am thinking that you might already guessed that it is a type of hosted zone that is accessible only within your VPC or your on-premise network, and it contains DNS records that map domain names to corresponding IP address or other resources that are only accessible within your private network, such as internal web servers or databases. So we need to make use of them as per our requirement. So I hope you get the point here. So one is the public hosted zone and the other one is the private hosted zone. And here you can see we have the resources that are publicly accessible with the public hosted zones connecting to the resources. And we also have the private hosted zone connecting to the VPC on the ones that are only accessible within your private network, such as internal web servers or databases. Don't worry about this. We will discuss more on this as well. So now it's time for us to talk about AWS Route 53 routing policy. So the AWS routing policy or AWS Route 53 routing policy is a key feature of Amazon's domain name system. It allows you to manage how your internet traffic is routed to your AWS resources based on specific rules or algorithms. That's why it is called a policy. And we have a lot of them in line for us. So let's check them out. First off, we have the simple routing policy. Second, we have the failover routing policy. Third, geolocation routing policy. And the another one, that is something that you guys had already asked me a lot of times that I had missed out on the previous video about where is geoproximity routing policy. We have the geolocation, but we don't have the geoproximity. So here it is. The next one is latency routing policy. We have the IP based routing policy as well. Next is also very interesting, that is a multi-value answer routing policy. And the last one, that is weighted routing policy. And don't worry, I'm not going to skip any one of these. I'll be discussing all of them. So let's get started. So the first one that we have here is simple routing policy. So with a simple routing policy, you create a DNS record for your domain name and specify the IP address or DNS name of your resources. When a DNS query is received for your domain name, Route 53 actually responds with the IP address or DNS name that you specified in the DNS record. And if the IP address or the DNS name changes, you'll simply update the DNS record to reflect the new value. So we have a list of information that you need to provide along with while creating a simple routing policy. So make sure that you check them out. And if you want to read along this, then please pause the video and go through this. It's really helpful. So here we have the routing policy, that is simple routing policy. The record name is basically this, the name of the domain or subdomain that you want to create the DNS for. For example, we have Pythoholic.com or Flipkart.com. The value is basically the IP address or the DNS name of the resource that you want to route the traffic to. For example, it could be either 192.0.2.1 or example.s3.website -uswest2.amazonaws.com. Next is the record type. So this is basically like it specifies the type of DNS record that you want to create. So for simple routing policy, this will be A. For IPv4 addresses, for quadruple A, it will be used for IPv6 addresses. And there is one more important concept called TTL in seconds. So this stands for time to live and specifies how long DNS resolvers should cache the record before requesting a new one. And the value that we have here is in seconds and can be set to any value, but typically it ranges from a minute or a few minutes to a few hours. Okay, so these informations are a bit elaborate, but let's understand this concept of TTL, which is very important. So TTL, or time to live, is a value that is set for each DNS record to specify how long the record should be cached by DNS resolvers and other DNS servers before it expires and needs to be refreshed. Here we all are trying to connect to Pythoholic.com. It reaches the resolver with a cache. Then it reaches the authoritative server for resolution. Here each of the user gets a response back, but the third user gets a new IP. Because of time to live. Here you can see at the 0th minute, www.pytholic.com resolves to 162.35.221, 22.1. So when the user actually sends the request, pytholic.com, the resolver actually sends the request to the authoritative name server. And once it gets the IP back, it actually caches it for 30 minutes. And it sends the response to the user, that is the same IP address that it collects from the authoritative name server. That is basically your 162.35.22.1. Similarly, this is what happens for the second user, which actually requests for the website within 15 minutes. And the next one, or the last one that we have here, is the user that actually exceeds the 30-minute threshold. And that is why the IP actually has changed during that time. So it actually sends the new IP address to the third user. And that is what is time to live. So time to live is value that is set for each DNS record to specify how long the record should be cached by the DNS resolver and other DNS servers before it expires and needs to be refreshed. And 30 minutes is basically a huge amount of time considering the availability of the servers. Like you might have a doubt, like what happens if during that period the server is not reachable anymore and it is trying to just provide the cached value to every user that comes along. So in this case, if the server IP specified in the DNS record is not reachable or has changed during the TTL or the time to live period, then the DNS resolver may continue to use the cached DNS records until the end of the TTL period. And that's a bad thing, isn't it? Which could cause issues for clients trying to access the domain. So for example, let's say you have a DNS resolver cache with a record with a TTL of 3600 seconds for a domain name that points to a specific IP address. So if the IP address becomes unreachable or changes during the TTL period, the DNS resolver may still return the cached record to the clients, even though it is no longer accurate. To prevent issues like this, yes, that's one thing that is really important. We want to prevent this. So it is important to regularly monitor the availability of your servers. And you must update your DNS records as needed, including adjusting the TTL value as well. So you must always try to shorten it if necessary, because that will actually help users to have a valid response every time they visit the website. So now that you are aware about TTL, let's move on to the second one, that is failover routing policy. As it is mentioned here, failover routing policy lets you route traffic to a resource when the resource is healthy, or a different resource when the first resource is unhealthy. So imagine this is you and you entered the URL and it goes to the AWS DNS. Here we have a region A where the instance is available to us. If the health check is successful, then the request will be what? The request will be routed to that instance as it is the default. Else it will move to the failover instance in the case of health check failures. That is why it is called the failover routing policy. Here as well, the information that you need to create the policy are provided here. But as we can see, we have 3 new entries. One is the failover record type. So basically it works like this. So when you visit a website, your computer sends a request to the DNS server to get the IP address of the website server. So normally the DNS server just sends back one IP address and your computer connects to that server to get the website content. But with a failover record type, the DNS server sends back multiple IP addresses, each one representing a different server. So the first IP address is for the primary server, the one that should be working normally. But if something goes wrong and the server actually stops responding, the DNS server automatically sends back the IP address of the backup server instead. So this happens without you even knowing it, and you can keep using the website or service as usual. The next one is health check. So we select a health check if you want Route 53 to check the health of the specified endpoint and to respond to DNS queries using records only when the endpoint is healthy. So we have already discussed health checks before. This is no different than what we have already discussed, so don't worry about that. And the last one that we have here is record ID. So this basically is the value that uniquely identifies the primary and secondary records, and that basically is used for distinction. So where to actually route? So we need records, right? So the record IDs are also present. Now the next one is geolocation routing policy. So geolocation routing policy is a fancy name or fancy term for a cool way to make websites faster for people all around the world. Basically it works like this. So when you visit a website, your computer sends a request to the DNS server to find the website's address. And with geolocation policy or routing policy, the DNS server can find or figure out where you are in the world based on your IP address, and then redirect traffic to the server that's closest to you. So this means that if you are in Europe and you want to visit a website that uses a geolocation routing policy, you will be directed to a server in Europe rather than the one in United States or Asia. By doing this, the website can load faster for you because the data doesn't have to travel as far. So here we have a user in India and another user in US. Here we create a record for the instance at AP South 1 region and another one at US West 2 region. So when the user in India tries to reach the instance, the record directs it to the closest instance, hence making it easier for the users to get the resource. And similarly, if you are in US, it will redirect it to the record that is nearest to you, that is in US West 2 region. So here as well, we have a list of information needed to create the geolocation routing policy. Along with these, we have the most important thing, that is the location. So you need to specify the region or continent or the country for which you want the Route 53 to route the traffic. So this is simple. Now let's talk about the most important one that everyone was talking about, that is geo proximity routing policy. So imagine you are out for a trip to a new place, but you know a few people here, but you are a bit strange in this location. So you have John, Shahrukh and Deepika. No, you're not in the Pathan movie, don't worry. But now after traveling for a long time, you're tired and you have to go to one of these friends to get some rest. Let's see. So from the place that you are right now, John's house is 100 meters away. Shahrukh's house is 200 meters away. And Deepika's house is 150 meters away. Now you need to decide where you want to go. The obvious option would be John, as he is the closest. That is the best option. You know that John is basically stupid and Deepika is a better friend. And you decided that you want to go to Deepika's house because she is a better friend. And in general terms, we call this with a particular term, which is, yes, it is a bias. So we are biased towards Deepika because we feel that she is a better friend. Remember this word bias. It will be. So geo-proximity routing is a type of DNS routing policy that sends website visitors to the servers closest to their physical location. It's like a GPS for the internet, helping websites load faster and reducing latency. But before you actually put into your head like, okay, geolocation routing is also the similar one, like it is similar to this, it's just the same because this also routes it to the nearest location. But hold on to that. I told you about the word bias, so that's what will help us understand the difference. So bias in geo-proximity routing is used to prioritize certain locations over others when redirecting or when directing website visitors to a closest server. So this can be helpful when some locations are more important than others, such as directing traffic to the server with higher capacity or faster response times. And bias actually allows website owners to customize their routing policy to meet their specific needs and improve the overall user experience. And by reading this, you might be thinking, what is bias, shrink, or expand? So don't worry about it. We'll talk about this. So when you're driving to a destination using a GPS, you can choose different routes to get there. Similarly, in geo-proximity routing, and bias is like choosing a preferred route to a server based on certain criteria. So for example, imagine you are driving to a friend's house, but there are two possible routes you could take. So one route is shorter but has a lot of traffic lights, while the other one is longer but has fewer traffic lights. So if you really want to get to your friend's house quickly, you might choose the longer route with fewer traffic lights, even though it is not the closest route. This example might fit in other countries, but in India, especially in Bangalore, you can't skip the traffic. So any route that you take will take a longer time. Okay, now let me break the ice here. So bias is nothing but a value. When it expands, it's a positive value between 1 to 99. That's a positive value, 1 to 99. But you might ask me, I saw the bias to be from 0 to 100. So value range of bias in geo-proximity routing is typically between 0 and 100. Yes, a bias of 0 means that all locations are treated equally and traffic is directed solely based on proximity of the server. And a bias of 100 means that the preferred locations are prioritized to the maximum possible extent, and the traffic is directed only to those locations even they are not the closest. So in practice, the most important or most common bias values used in geo-proximity routing are between 1 to 99. When it expands, that's the positive value. Now when the bias actually shrinks, it will obviously be a negative number between -1 to -99. The negative bias shrinks value or negative bias shrink value means that the preferred locations are narrowed down to a smaller area around the ideal location. So the absolute value of the bias shrink determines the size of the area. For example, a bias shrink of -10 would create a smaller area around the ideal location than a bias shrink of -5. Okay, so I hope you got the point here. Then let's take an example. So this is a region map, and let's start off with the bias value of ±0. So this is a zero biased map. So there is no bias. The request will go to the nearest resource that's available. So it could go to any of these locations, 1, 2, 3, 4, or 5. Let's give expand value or expand bias to US East region, North Virginia, which is the number 2 in the map. So here you can see when we added a +25 bias, so now the traffic is routed to the resource in that region from the larger portion of North America than it was previously there, and from all of South America. So previously, as you can see here, this was a narrow zone, and we increased the bias of +25 for US East North Virginia. You can see there's a lot of region that has been covered here. So we are trying to be biased towards North Virginia by increasing the bias with a positive value and expanding this. Now what happens if we shrink that? So let's suppose we shrink it to -25. So change the bias to -25 for the US East North Virginia region. So here, as you can see, the traffic is routed to the region in that particular region from a smaller portion of North America or South America than previously, and more traffic is routed to the resources in the adjacent regions, like it could be 1, 3, or 5. And this is how you can visualize the bias. And remember, to use geo-proximity routing, you must use Route 53 traffic flow. Remember this. For geo-proximity routing, you should use Route 53 traffic flow. Now let's do some calculations to understand this better. So here is a source of query or source of the query, like the origination of the query. And we have a resource that we can access, and it's 150 kilometers away. And another one that we have here is just 100 meters or 100 kilometers away. So basically, when you see this, the most obvious option for us to choose is like web server B, because it is 50 kilometers lesser than web server A. So that's a genuine choice, isn't it? Now let's see the effect of bias in this. So a positive bias distance is the actual distance multiplied by 1 minus bias value by 100. So this is the positive bias. So bias distance is equal to actual distance multiplied by 1 minus bias by 100. The negative bias is basically your actual distance divided by 1 plus bias by 100. So when we have the value of the bias that is positive, Route 53 treats the source of the DNS query and the resource that you specify in geoproximity as if they were closer than they really are. So let's suppose you're looking into the rear view mirror and the objects are closer than they appear, isn't it? Because there is a bias in the lens. So we have a record A for web server A, which has a positive bias of 50. So here the web server A has a positive bias of 50, and record B here, or web server B here, has no bias at all. So now let's see the calculation here. So the bias is 50. The bias distance is actual distance multiplied by 1 minus bias by 100. So bias distance for the web server A, as the actual distance is 150 kilometers, so 150 kilometers multiplied by 1 minus the bias value, that is 50 by 100, which is obviously 150 multiplied by 1 minus 0.50, that is basically 0.50. So 150 multiplied by 0.50 is 75 kilometers. So now, as you can see here, so now based on our calculations, if the record has a positive bias of 50, then we'll think it is only 75 kilometers. So for the query, the 150 kilometers is just 75, and compared to 100, the 75 looks closer. So it goes to the resource which is located 150 kilometers away, even though in reality it is the farthest one. So now you see the importance of bias. It can actually trick you into thinking that the resource is closer even if it is not. So you might say, what's the advantage here? Why are we doing this? So for example, a website owner wants to direct traffic to a server that has more available capacity or is better optimized for a certain type of request. So even if it is not the closest one, by using bias, they can prioritize that server over others and ensure that traffic is directed to it as much as possible, while still taking proximity into account. So that's a very beautiful concept, and bias is something that is a really interesting subject. And I would suggest you to please go to the website and the documentation and read more about this. This is really interesting. Now we come back to the latency routing policy. This is one of my favorites. So let's, for our imagination, if you are in New York and you're visiting a website that has a server in both New York and California, the website will automatically direct you to the server that has the fastest response time, which is probably the one in the New York location. So this means you'll get a faster and more enjoyable experience on the website. So latency based routing is very helpful, or really helpful, for websites that have a lot of global traffic and needs to ensure that visitors have a good experience no matter where they are in the world. It's like magic tool that makes the internet faster and more reliable. Here as well, if the user is in India, it'll reach the one that's closer. Here we have one server that is in AP South 1. So based on the routing based policy, it'll reach AP South 1 location. But if suppose there is another one that is closer to this or than this, then it will be redirected to that. But in case if you don't know what latency is, so latency is the amount of time it takes for a data packet to travel from the sender to the receiver and back again. In other words, it's the delay that occurs when the data is transmitted over a network. So for example, if you're streaming a video from the website, latency would be the delay between you clicking the play button and when the video actually starts playing. If the latency is high, it may take several seconds for the video to start, which can be very frustrating for the users, isn't it? So in the context of latency based routing, the focus is on finding the server that is closest or which can provide the lowest latency for the user, which helps to ensure a faster and more reliable user experience. And here as well, we need to provide information to create the latency based routing. Along with these already known parameters, we have a new one, that is the region. Yes, you need to provide the Amazon EC2 region where the resource that you have is, or the resource that you have in this specific record resides. So you can also create one latency record for each Amazon EC2 regions. You aren't required to create latency record for all Amazon EC2, but that's a good thing. And let's move on to the next one. This is also a very interesting one, which is IP based routing policy. Yes, the IP based routing policy is a method to direct traffic or network traffic based on the IP address of the sender or receiver. So each device connected to a network is associated or assigned a unique IP address that we all know, which can be used to identify the device and route traffic to it. So when data is sent between devices, routers use the destination IP address to figure out where to send the data next. Think of it like a postman who reads the address of a letter to figure out where it needs to be delivered. But the amazing use case for IP-based routing is basically like it is used in big networks, like in large offices or schools, to make sure data is sent to the right place efficiently. So it's like a traffic controller, making sure that each car on the road is going to the correct destination. So how it actually works is, let's suppose you have a user here which has the IP address of 203.0.113.5. Here the IP based routing policy will try to match this IP address to a matching CIDR block, that is 203.0.113.0/24, and the user will be directed to this resource itself. So in turn, you can say that it is matching the query IP to the CIDR of the resource, and thus the user is directed towards that resource itself. So that's how it works. So let's suppose you have something that is matching for this CIDR block, then the user will be redirected to this particular resource. Now that it matches this CIDR block, so this user gets redirected to this particular resource block. That's how the IP based routing works. Now it's time to talk about the multi-value answer routing. Multi-value answer routing in Route 53 is a feature that allows you to route traffic to multiple resources based on the routing policies you specify. So this means that when routing or Route 53 receives a DNS query for a domain name, it can respond with up to 8 different IP addresses, which are assigned to different resources such as EC2 instances or load balancers or S3 buckets. So with multi-value answer routing, you can improve the availability and performance of your application by distributing traffic across multiple resources. So if one of the resources becomes unavailable, actually Route 53 can automatically redirect traffic to other available resources. And this can also help you, achieve higher availability and reduce the risk of downtime. So let's suppose you are a user here and wants to access the resource using the URL www.pythoholic.com. Now with multi-value routing policy, the DNS server will return it with multiple IP addresses for the resource. And based on the factors like availability, health check, it'll help you reach the destination. But you might think, how does it choose among several IP addresses? So Route 53's multi-answer routing policy uses a round-robin method to distribute traffic among the available IP addresses. So this means that when a Route 53 receives a DNS query, it responds with a different IP address each time, cycling through the available options in a circular pattern. So this way traffic is evenly distributed among the available resources. Additionally, Route 53 can use other routing policies as well, such as latency based or weighted routing, to choose the best available resource based on the factors like geolocation or geographical location or performance matrices. As rightly mentioned here, if you associate a health check with a multi-value answer record, Route 53 responds to DNS queries with the corresponding IP addresses only when the health check is healthy. Yes, if it is healthy, and if you have associated it to the record, then it will check whether it is healthy and it will return that if that is healthy. So if you have 8 or fewer healthy records, Route 53 responds to all DNS queries with all the healthy records. When all records are unhealthy, Route 53 responds to the DNS queries with up to 8 unhealthy records. So overall, this gives multiple answers. That's the gist. And here it is. And this is how it looks like. So here you can see we have 3 entries of a record here for pythoholic.com with 3 different health checks, A, B, C. And that's what the DNS returns. And remember, you can have up to 8 such entries. So we have the name, the record type, the value of the IP address for the given record, the time to live, 60 seconds, set ID, and the health check. And remember, if you don't associate a health check with a multi-value answer record, Route 53 always considers the record to be healthy. So that's something that you need to be careful about. Now, the last one is weighted routing policy. So when it comes to the next one, when it comes to weighted routing policy, which is also very interesting, the weighted routing policy is a feature of Route 53 that allows you to distribute traffic to multiple resources in a way that's based on weights or percentages that you specify. So for example, let's say you have two resources, resource A and resource B, and you want to distribute traffic between them. With weighted routing policy, you can assign a weight or percentage to each resource, such as 70 for resource A and 30 for resource B. This means that for every 100 request, 70 would go to resource A and 30 would go to resource B. And the weight distribution is computed as weight of the specified record divided by sum of the weights of all the records. So now based on that, let's see this. So we have the value A. Let's suppose the value A is 1 and value B is 255. So weight A will be weight for the specified record by sum of the weights of all the records. That is 1 by 256th of traffic. The weight B will be the value, that is 255 by 1 plus 255. So let's suppose you have 100, then it will be 100 by 256 and 156 by 256. 0, 0 will be 50%, 50%, and 0 to 56 will be 0 and 256. So when we say 1 by 256 of traffic, it means that, so 1 by 256 of the traffic will be gone to the value A or the server A, and 255 by 256 of traffic will be gone to weight B. So that's how it is computed. And here as well, we have the parameters needed to create the weighted routing policy. But the most important parameter here is, yes, the weight. So the weight is the value that determines the proportion of DNS queries that Route 53 responds to using the current record. So you know how sometimes your website or application can crash or become unavailable? It's super frustrating for users, right? AWS Route 53 Health Check is a feature that helps you prevent that from happening by checking the health and availability of your servers and other resources. Basically, you set up these health checks to ping your resources periodically and make sure they're working properly. If a resource fails, then the Route 53 can automatically stop sending traffic to it and redirect traffic to a healthier resource or a healthy resource. This helps ensure that your application or website stays up and running, which is obviously super important if you want happy users. So let's talk more about how Route 53 checks the health of your resources. Here let's see the configuration of the health check on Route 53 for your usage. And as I already told you, AWS Route 53 Health Check is a feature that helps you prevent problems from happening by checking the health and availability of your servers and other resources. So for that, we actually send a request and it basically hits the resource that works just fine. So it's a happy resource and you get the proper response back. Moving on, we send the request to a bad resource. We get the error response if the endpoint doesn't respond to a request. And then Route 53, what it does is basically it starts to count the number of consecutive requests that the endpoint doesn't respond to, and based on the way we have configured the health check, it will fail it. Let's suppose you're checking for unhealthy responses up to 3 times in your health check. If it doesn't respond 3 times, it'll mark the endpoint as failed. Post which we integrate it with CloudWatch alarms to notify the users with a notification about this error state using AWS SNS service. So if you configure a notification for the health check, CloudWatch triggers an alarm and uses Amazon SNS to send notifications to the specified recipient. So with the proper configuration with health checks, you can keep your resources healthy. So as I already told you, these CloudWatch alarms, SNS topics, and all these don't get configured by default. You have to configure them yourself. So let's do this once again. Let us recap this once again. So the point number 1, we configure the health check on Route 53 for our usage. We send a request here. It hits the resource that works just fine. So it's a happy resource and you get the proper response back. Moving on, when we send the request to a bad resource, we get the error response. That is, if the endpoint does not respond to a request. Then what Route 53 does is it starts to count the number of consecutive requests that the endpoint doesn't respond to, and based on the way we have configured the health check, it will fail it. Post which we can integrate it with CloudWatch alarm to notify the users with a notification about the error state using AWS SNS. If you configure a notification for the health check, CloudWatch triggers an alarm and uses Amazon SNS topics to send notification to the specified recipient. So with the proper configuration with health checks, you can keep your resources healthy. And here we are. So let's talk about the type of health checks we can make use of using Amazon Route 53 health checks. So the first one is the health check that can monitor an endpoint. The second one is the health check that monitors CloudWatch alarms. Third one is the health check that monitors other health checks. And the last one is Amazon Route 53 application recovery control. So let's discuss about them one by one so that we get a better understanding of what exactly they do. So let's suppose you have a website or application, you make sure it's always available. So you want to make sure, isn't it? You want to make sure that it's always available and working well for your users. AWS Route 53 Health Check is a feature that helps you to do that by regularly checking to see if your servers or other resources that you have are healthy. You can choose how often and from where these health checks send requests to your resources, and they evaluate the health of the resource based on the response time and consecutive checks. And Route 53 then looks at all the health checks or the health check data or the health check data and considers the resource healthy if more than 18% of the health check reports is reported to be healthy. So this way, if there is a problem with one or two health checks in a particular location, it won't make your whole resource look unhealthy. So that's a good thing. And there are different type of health checks you can use, like HTTP, HTTPS or TCP, and each one has different requirements for response time and status code. So that is why it is written here. For HTTP and HTTPS health checks require a TCP connection within 4 seconds and HTTP status code of 2 or 3x within 2 seconds. And as I already told you, HTTPS health checks don't validate SSL TLS certificates, and the TCP health check requires a TCP connection within 10 seconds. So these are basically the criteria based on which it can mark the instance healthy or unhealthy. Now AWS has this cool thing called calculated health check that helps you keep an eye on a bunch of other health checks at once. So basically you can set up a parent health check that monitors up to 255 health checks or child health checks. So the parent health check looks at how many of these child health checks are healthy and compares that number to a certain threshold for the parent health check to be considered healthy. So basically a calculated health check monitors the status of other health checks, and the parent health check that you have monitors up to 255 child health checks. So in this case, if like enough child health checks are healthy, then the parent health check will also be considered healthy. It's a way to quickly see if a bunch of different resources are working properly without having to check each one individually. So that's a very good thing. And this comes down to the last topic of the day, and that is going to be so let's talk about, so you know how sometimes you use CloudWatch to monitor things like server performance or disk space? Well, with AWS Route 53, you can create a health check based on a CloudWatch alarm. So basically what it does is the health check will monitor the data stream for the corresponding CloudWatch alarm. If the data stream shows an OK state, then the health check is healthy. So if it shows an alarm state, then the health check is unhealthy. And if there is no sufficient information to determine the state, like if the data stream is incomplete, then the health check status will depend on a setting called insufficient data health status. And one thing to keep in mind is that AWS Route 53 doesn't support cross-account CloudWatch alarms. So you can only use CloudWatch alarms that are in the same account as your Route 53 health check. So remember this, Route 53 doesn't support cross-account CloudWatch alarms. So you can only use CloudWatch alarms that are in the same account as your Route 53 health checks. Finally, when you first create a health check, it's considered healthy until there's enough data to determine the actual status. So it might take a little while for the health check to start showing accurate information. So make sure that you keep an eye on the health check, and the best thing is to get notified. So if you have the option, then please go ahead and create a CloudWatch alarm, which triggers a SNS notification that can send you notifications to your email or your mobile phone via SMS. And that's a very good way to deal with this. I hope you enjoyed this. Let's move on. An NSLookUp can be a helpful tool for understanding how domain names map to IP addresses and also for troubleshooting network issues. To use NSLookUp on Windows, you can open the command prompt and type in NSLookUp followed by the domain name you want for the query. For example, to look up for the IP address of www.google.com, you would type NSLookUp space google.com and press enter. The result will display the IP address associated with that domain name as well as information about the DNS server used to perform the lookup. You want to see how it works? I can just type NSLookUp space www.google.com. I don't even need to type www, but it's okay. And just type enter. So the non-authoritative answer that we have here is 142.250.205.228. And you can do this for other websites as well. NSLookUp www.twitter.com. Yes, you find the non-authoritative answer. Twitter.com is 104.244.42.1. So you can just come to https dnschecker.org nslookup.php for the website, and you can just type youtube.com, and we can use the DNS server Google and just click on show NS records. Yes, it will show you all the name server records for youtube.com. Now let's think and understand this once again. When we want to visit twitter.com, so we enter the URL and it checks for the IP address with the internal DNS server, which is the resolver, which helps resolve our domain to the IP address. If it doesn't find it, it checks with the root level domain, which contains the name server records, like the list of name servers that you can visit to resolve your query, like hostname servers and hostname alias, and they are like which names they are being stored as. Like for example, let's suppose we have pythaholic.com, we might as well create a name record or CNAME record like shop.pythaholic.com, which resolves to pythaholic.com. So we need to know the hostname aliases as well. So these all information are provided by the root level server. That is where we get the referral data. Now with that data we go to the top level domain server, which are responsible for resolving domains ending with .com, .net, and in our example that is twitter.com or google.com or youtube.com, which then passes the referral to a secondary level domain. Understand that a second level domain is the domain name that appears immediately to the left of the top level domain in the domain name, such as Twitter in twitter.com. And here the DNS server responds with the authoritative DNS records for twitter.com, including the IP address of the web server hosting the www subdomain. So when we visit twitter.com, we enter the URL and it checks for the IP with the internal DNS server. If it doesn't find, it checks with the root level domain, which contains the name server records, like the list of name servers that you can visit to resolve your query. That is where we get the referral data. Now it sends the data, or now with the data that we have, we go to the top level domain server, which is responsible for resolving domain names ending in .com, .net, such as twitter.com, google.com. And here the DNS server will respond with the authoritative DNS records for twitter.com, including the IP address of the website hosting the www subdomain. And that is how it reaches to the client. And that is how the IP address reaches to the client. Now let's understand the URL in a bit more depth. So this is the URL that we have. So HTTPS, this is the protocol used to access the website, which in this case is HTTP with the added security via SSL TLS encryption. That is what makes it secure. So this is your schema or protocol. www is the subdomain of the website address, typically used to specify a specific server or service within the domain. ABC, this is the second level domain or SLD or main domain of the website. And .com, this is the top level domain of the website address, which typically represents the type of organization or location associated with that domain. 8080, this is the port number used to connect to a specific service or application on the server. Search, this is the page path that you already know, This is the page path or directory where the request content is located on the server. And Q equals example. This is your very own query string parameter used to send additional data to the server for processing. In this case, the search query is example. So once again, I want to clarify this. So www is your subdomain, ABC is your second level domain, and the .com is, yes, your top level domain. So HTTPS is your schema or protocol. This www.abc.com is your host name or fully qualified domain name, FQDN. This term is something that you will hear a lot. So try to remember this. www is the subdomain. ABC is the second level domain or SLD. .com is your top level domain. 8080 is your port. Page path is search/search. And you have the query string that is $Q equals example. So if you can have $equals mobile phone, $equals reports, anything that you want to search, but it sure has to be present on the website. Otherwise it will not be reachable. Thanks everyone for watching this video on Route 53. I hope you found this introduction to Route 53 informative and useful. In the next video, we will dive into a demo and we'll explore some of its features in great detail. So be sure to subscribe to my channel to stay updated and get notified when the next video is released. With Route 53, you can manage your DNS and domain name service with ease and reliability. So don't miss out on this AWS tool, which is a powerful one. Thanks again for watching. I'll see you in the next one. Until